All right, so here we are with our second lesson of Unit 6, Translations in the Coordinate Plane. So a translation, we get more specific here with each of these transformations. The first one's translation moves every point of a figure in the same distance and the same direction. Translation can move a figure left to right and up or down. Translations are also thought of as a slide, so you're sliding the shape around the coordinate plane. We're going to take a look at an example here. Okay, so in this first example, translate triangle ABC 5 units left and 2 units down, and then answer the corresponding questions. All right, so this is as simple as taking each of these points and moving it the 2 directions that they're telling us. So this is telling us left and down. Okay, so we're going to take each point and we're going to count 5 left, 2 down. Okay, so point B, 5 left, 2 down, and that's going to be B prime. Okay, point A, 5 left, 2 down, that's going to be A prime. Point C, all right, that's going to be point C prime. Okay, and then we want to connect those, all right, to make our new triangle. Oops. All right, so that's our new, okay, image. So let's go ahead and do these other parts here. In part A, record the vertices of the pre-image and the image in the table. Okay, so I'm going to go ahead and label these A, B, C. This is our pre-image. So 2, 4 was point A. All right, it looks like 6, 7 was point B. And 7, 3 was point C. Now, when I look at my image, okay, it's going to be A prime, B prime, C prime. I want to record each of those coordinates, okay? So it looks like I got -3, 2. All right, I got 1, 5. And then I got 2, 1. Okay, so describe how the transformation affected X and Y values in each vertex. Okay, so we're trying to come up with an algebraic way to do this as well. So if I'm moving 5 units left, okay, if you'll notice my X values here in each of my coordinates, all right, 7 and 2, subtracted 5. 6 and 1, subtracted 5, right? So the idea here would be that the X values, we subtract 5, okay, to get the new X value. All right, well, what about the Y values? Okay, since we move them 2 units down, again, observe your Y values right here. Okay, so I have a 3, ended up with a 1, that's -2. A 7 ended up with 5, it's -2. Right, a 4 ended up with 2, it's -2. All right, so for my Y values, all right, I subtracted 2. How could we summarize the effect of the transformation algebraically? Well, here's where we want to take this and create an expression. So x minus 5, comma, y minus 2 would be an algebraic version. Basically, what's that telling us is that we're subtracting 5 and 2 to represent the left movement and the down movement of my pre-image to my image. All right, I want you to go ahead and hit pause. I want you to try this example here on your own. All right, thanks for doing that. Let's check it out and see how you did. So 4 units right, 3 units up. Okay, so that's what my image should look like if I shift my pre-image 4 to the right and 3 up. Okay, if I go through and record each of my vertices. All right, so my image D prime, -3, -1. I got 0, 4 for E prime, and I got 1, -2 for F prime. If I'm summarizing this or describing what happened, all right, to each of these vertexes, all right, for X, I added 4 right, add 4. And for Y, I added 3. Okay, so +3. If I want to summarize that algebraically, I would say X plus 4, comma, Y plus 3 for my coordinate. All right, let's turn the page. Okay, here we go. Use the translation of GHIJ to answer questions A through C. So we'll notice here that the pre-image, right, is in the 4th quadrant. The image is split between the 2nd and 3rd. Give a verbal description of the translation. So I'm trying to figure out how far it moved, basically. Okay, so I want to trace these steps here, if you will. Okay, so my H number goes from there to there, and then there to there. So how far did it move left, and how far did it move up? is what I'm trying to determine, okay? So I got 1, 2, 3, 4, 5, 6, 7 left. Okay, so left 7. And then I got up 1, 2, 3, 4, up 4. Okay, so my verbal description would be left 7, up 4. How would you represent that translation algebraically? Okay, I would take x minus 7, and I would take y plus 4. Okay, what do you notice about the line segments and angle measures from the pre-image to the image? Okay, same size and shape, right? So they're trying to get us to observe the fact that these two are still congruent. Okay, the size and shape didn't change whenever we slid the figure to left and up. All right, the coordinates for triangle KLM are given in the table. Eric plans to translate the triangle 9 right and 9 down. Describe how you could find the coordinates for the image. And this is why we want to be able to jump right to that algebraic description, okay? Because if we're going to go 9 right, we're going to go x plus 9. If we're going to go 9 down, we're going to go y minus 9. Now, all I need to do is that operation to the x values, all right? So here's my x values. All right, I want to add 9 to each of them, okay? So negative 7 plus 9 is 2. Okay, negative 2 plus 9 is 7. All right, negative 2 plus 9 is 7. Okay, now my y values, all right, it says here I want a minus 9 from each of these. So 2 minus 9 is negative 7. 2 minus 9 is negative 7. 7 minus 9 is negative 2. Okay, so that's how I will get the coordinates of my new image. Okay. Coordinates of a pre-image and image are listed. We want to try to figure out what translation happened here. So this is a pattern, okay? So for your x numbers, if you were at 12 and you ended up at negative 1, what happened? Okay, I think we moved left 13. Okay, if I was at 7 and I finished at 14, I think I moved up 7. So I would have x minus 13, y plus 7, all right, is my translation. Okay, again, I'm looking for a pattern here, okay? So I'm starting at negative 6, I'm ending at negative 5. So that means I moved right 1. Okay, I'm starting at negative 8, I'm ending at positive 2. So that means I moved up 10. So x plus 1, y plus 10. Okay, last one here. All right, started at negative 3, ended up at negative 9. That's left 6. Started at 6, ended at negative 1. That's down 7. All right. So algebraically, I would say that's x minus 6 and y minus 7. If you have to use a coordinate plane, okay, and plot those 2 points, go for it, and then you can count blocks. All right, the goal would be to be able to do it without that. Last, the graph shows translation, triangle ABC. Mark each statement as true or false and correct any false statements. The triangle was translated from quadrant 2 to quadrant 4. Okay, so remember that the image, okay, is the prime numbers and the prime variables, and the pre-image is the plain ones. So this looks like it went from 4 to 2, not 2 to 4. So this would be false. It went from quadrant 4 to quadrant 2. Now that's semantics, but still important. The translation can be represented by x plus 10 and y minus 10. Okay, so I think we have that backwards, right? So it looks to me like A to A is going to go 2 to 8, right? And then negative 3 to 7. So I think we have that backwards. I think we should have x minus 10 and then y plus 10. So this was false. The translation preserved congruence and orientation of the figure and vertices. That is true. How do we know that? Okay, well, vertex B is still pointing to the right. Okay, so the orientation of the figure is the same. And then the order of the letters. So ABC is clockwise movement. ABC is clockwise movement. So the order of the vertices didn't change either. So that statement is true. All right, hopefully you copied your notes down, and I'll see you in class.